Hello everyone. In this video, we'll learn how to make a spur gear. In the previous videos, we've learned introductory operations in Creo. Here we know how to use extrude, how to do some basic sketching, and how to use revolve. And to make a spur gear, we'll essentially just be making a 2D sketch and then extruding it in the third dimension. At the end, when you're done, you should be able to get a spur gear like this. I've shown these in the class as well. I have a 3D printed spur gear over here and a bigger one over here, and the eventual idea is that you'll be able to have your individual spur gears that you make today in Creo 3D printed, and then you'll pair up with a colleague and make a gear train. So that's why it's very important that you follow the instructions about making an involute profile properly. Otherwise, your gears won't be able to mesh, and in addition to you potentially losing points, you'll have to remake your involute profile and figure out which of the two team members made a mistake here. Try to follow the portion where we make an involute profile carefully. All the instructions here, not in complete detail, but a list of all the major tasks should be provided, should be available in this sheet that has been uploaded on the LMS, and I'll quickly go through the requirements for making the gear. And I'm expecting that you know how an involute profile is made, or what an involute profile is. Remember, I referred you to that YouTube video that you can access through this hyperlink, which I thought was very well explained, which explained the concept very well. And I expect you to read these portions of your textbook on mechanical engineering design, because you'll have to refer to those portions to perform some of the calculations. So we need to make a spur gear with a diametral pitch P of 8 teeth per inches. So from here, take note that we are working in inches. So in Creo, we won't change the system of units to millimeters. N number of teeth. If you scroll down, you'll be able to see how many number of teeth you individually have to work on. So it could be anywhere, any number between 8 and 24. So I've assigned each student an individual n number. For practice, I'll be working with n8. So for me, the diametral pitch is 8, and the number of teeth of that gear have to be 8 as well. And that incidentally is this gear. It has 8 teeth. The pressure angle should be 20 degrees, and the axial thickness, this thickness should be 1 centimeter. The profile has to be involute, and the gear is expected to be mounted on a 1 centimeter shaft, so it should have a hollow inside with an inner diameter of 1 centimeter, and the mounting is expected to happen using a square key. So if you look closely, it should have a key slot as well. So those are the general requirements. So let's get started. I'll place this on the left side, and it can serve as a checklist, even though I won't be referring to it very frequently. So let's open up Creo, start a new project like you always do. I'll call it spur gear, and I'm going with the default template. The system of units should be in inches. You can verify that. I want to display my datums, so let's enable datums. I had them hidden previously, and the first thing that we need to make is we need to sketch the pitch circle, and I have some notes over here, so I'll be referring to those, but you can look at your textbook to calculate the pitch circle diameter, and I'll quickly be showing you where those equations are, and they're all in chapter 13. So from this equation, you know the diametral pitch, the capital P, you know the number of teeth n, and you can calculate the diameter of the pitch circle. So for a diametral pitch 8 teeth per inches, and n, the number of teeth being 8, d comes out to be 1 inch. So the first thing that I'll do is that I'll make a sketch. I'll start a new sketch, select whatever plane you want. I would recommend you sketch in the XY plane, because later on when you make a curve of the involute profile, you'll be using an equation, and that equation I've provided over here. We've talked about that in class, that this is the equation of a circular involute, and the equation, the way it's written over here, is for the XY plane. You can very easily convert this into XZ or YZ, but if you want to use it as is, do everything in the XY plane. So I'll make a circle, and I'll give it a diameter of 1 inch. Yes. So that was the first step that I did, which was to make a pitch circle. And you'll be making a lot of circles, so make sure that you are appropriately naming everything in the model tree. So I'll call this my pitch circle. Next, I'll make the base circle, and remember, the base circle is the circle from which your involute profile starts. Everything below the base circle is non-involute. You just connect your tooth profile along a radial segment, along a straight radial segment below the base circle. So if you refer to your textbook and its simple trigonometry, if this is your pressure line and you're given the pressure angle, you can calculate the diameter of your base circle from the diameter of your pitch circle, and the equation that you'll use would be this over here. Everything is in terms of radius, but you can use that in terms of diameters. So knowing the pitch angle and the pressure angle and the pitch circle diameter, I can calculate my base circle diameter. The base circle diameter for me is 0.94 inches, and this is with a pressure angle of 20 degrees, which has been provided. So I'll make a new sketch again on the same plane, and this too will be a circle, and it will have a diameter of 0.94, and this will be my base circle. Eventually we'll hide many of these sketches that we are making, but to aid us in making that involute profile and the profile of the tooth, we need to make these sketches. I'm sure there are other ways you could do that. You could make all of the sketches in this, all of these circles in the same sketch. You could use construction lines. Feel free to experiment, and if you find a more elegant way of doing this, please do share, and we can discuss that in the class. So we've made our pitch circle, we've made our base circle. Next, we'll make the involute profile of the tooth, and we've talked about how involute profiles work. So we'll make the involute profile using a feature that Creo has, where you can make curves. Curves are 2D entities. Using an equation, you can prescribe the equation that you want the curve to follow, and Creo will create a curve accordingly. So instead of going to sketch this time around within the model tab, we will use this option of curve from equation to make a curve using the equation of involute. So datum, curve from equation. And the first thing that you need to prescribe over here is the coordinate axis with respect to which the curve would be generated, and we are using the default coordinate system. We don't have any other coordinate system, so it doesn't even matter. You select the coordinate system over from here, and that satisfies this requirement, and then prescribe the equation. We'll write the equation of involute in a syntax that Creo can follow. I've provided that in the note here. You can refer to additional material about how the equation is generated, and you can uh, explore that at your own time, and I'm happy to discuss that with you if you want. So this is the equation that we'll be using to prescribe the curve of an involute. In my case, the radius of the base circle is 0.47, hence I'm entering r is equal to 0.47. Remember that the involute curve starts from the base circle. So over here, be careful about what radius you enter. You shouldn't be entering the radius for the pitch circle. So the radius for the base circle, for my case, is 0.47, and this hopefully should generate a curve in the xy plane, because this equation is written in the xy form when I press OK, and that's what happens. So this new curve has been generated, curve from equation. I'm happy with this. I'll click OK, and if you see over here, I can see that curve. I'll call it my involute. Now hopefully your things are making sense. What we've done so far is that we've made this involute portion of the curve. We don't know where to stop this, because this will stop at the addendum circle, and it will go on till the addendum circle. So we'll have to make the addendum and the addendum circles to truncate this curve, but we have a curve which we can work with now. Make tooth involute profile. So we've done that, and as we were just talking, the next thing that we need to do is to make addendum and addendum circles. And if you go to your textbook, you can calculate your addendum and addendum values. Addendum is the radial distance from the pitch circle to the outermost edge of the gear, and addendum is the radial distance from the pitch circle to the innermost point where your tooth ends. For my case, I have calculated my addendums, my addendum and dedendum, and I'll use that to make addendum and addendum circles. So I'll make a new sketch. Let's make the addendum circle first. So the addendum circle, the diameter of this would be the diameter of my pitch circle, which for me is 1 plus 2 times the addendum, and the addendum for me is 0.125. We'll press OK, and in this way we have created our addendum circle. You can name it as you wish, but it should be able to convey that this circle is your addendum circle. Similarly, we'll make our addendum circle. New circle, and the diameter over here would be the pitch diameter, which is 1 minus 2 times the addendum, and the addendum in my case is 0.15625. This would be my addendum circle, and it has a diameter of 0.69. I'm just noting that down because we will need that later. Okay, so now we have our addendum and addendum circles, and we know that our involute profile, which starts from the base circle, ends at the gear, because the addendum circle marks the top of our gear, so there is no point in having this go beyond the addendum circle. So we'll truncate this, and for that, select your curve, select your involute curve from here or from the graphical interface, and then within model, use the trim command. It should be somewhere over here. Here it is. I couldn't see it because I had the window not completely maximized. Here, select your curve, select trim, and then select an object which would define where you want to trim that curve. I want to trim the involute curve at the addendum circle, so I'll select that curve, and the arrow tells me which part of the curve will be retained. So I want this part to be retained, and when I click OK, everything to the right of the addendum circle, outside of the addendum circle, has been removed, and my involute profile has been trimmed. And this is what we'll be working with moving forward. So now that we've trimmed our involute profile, we need to start making the profile of our tooth. So all we have at this stage is one edge or half of one edge. Now we want to make the other edge. And for that, we need to know what the thickness of our tooth is. So we need to know our tooth thickness. And the tooth thickness is measured along the pitch circle. And there's a way you can calculate your tooth thickness using this formula. The only thing that you need to know is the diametral pitch, capital P, which you know, and you can calculate the tooth thickness, which I've done over here, and it comes out to be 0.196. So what I'll do now is that I'll start a new sketch, and within this sketch I will use this involute curve that I have and information about the tooth thickness and try to make one tooth, the cross section for one tooth. The first thing that I'll do is that I'll make a projection on this plane within sketch of the involute. So project from sketching and select the involute, which is a curve which exists in the same plane, but it's not a part of this sketch. We want it to be a part of this sketch. So select OK, and now we have the beginning of our sketch. And the next thing that we want to do is to mirror this to create a symmetric copy of this, but how far should it be? And that would be determined by the thickness of the gear of the tooth. The way I'm doing it is by making an arc, which I'll later get rid of. So I'll use the center and end arc. Just follow along, and hopefully it will make sense in a minute. So start an arc, and this is my pitch circle. So the thickness should be measured as an arc along the pitch circle. So start making an arc from here and stop it anywhere you want. And now we need to know what is the arc length of this arc that we just created. So to have Creo show you the arc length, select dimension, select the starting point of your arc. While holding down control, select the ending point of your arc. Still, while holding down control, select the arc. With all three of these entities selected, press the center mouse button and Creo will display the arc length. So for us, the thickness would be the length, the thickness of the tooth would be the length of this arc, which is 0.196. So our tooth would be this thick. I hope that's all right. Let me just verify that very quickly. So the thickness will be pi over 16. Yeah, so that is 0.196. But instead of making the entire arc, I'll only make half of it. So 0.196 divided by 2, which after some truncation is around 0.1. So I'll make that arc, and now what I'll do is I'll try to mirror this involute region about half of the thickness of the tooth. So for that, I'll make a center line starting from the center of the gear such that it passes this end of the arc, which marks half of the thickness of the tooth. There are other ways of doing this as well. Feel free to explore and do share if you find something good. And now I'll select this involute profile, and I'll use this mirror command within Creo, and this is within sketching. So mirror allows you to, as the name suggests, mirror any entity that you've created, any entity that you've sketched across about a center line. So I made a center line that would be my mirror essentially, and I've selected the entity that I want to mirror. Then I'll select the mirroring line, and Creo automatically creates a symmetric entity about that line for me. So our tooth profile is starting to emerge. I'll get rid of this arc that I created for the thickness. Select it, delete it, I don't need that anymore. We'll use the center and end arc again to complete the top of our gear. And another thing that we need to do is to complete the bottom portion, and the bottom portion, anything below the base circle, will not be involute. It will just be a radial segment, a straight line connected to the center of the gear, but we have to fill it or round a certain portion of that radial segment, so that the mating action of the gears, that's uniform, that's there is no interference while that happens. And for that we need to know what the clearance circle is. If I can show that over here, what I'm trying to make, that's this filleted radius. So up to the base circle, let's say this is the base circle, up to the base circle we have the involute profile, then we have a straight radial segment, and after that, between the clearance circle and the dedendum circle, we have a filleted segment. So we need to make our clearance circle, and you can find the clearance for your gear using this formula. So the difference between the dedendum and the addendum in inches in this case is your clearance. The clearance for my gear is 0.031. I'll do is that within this sketch I'll make a circle. Let's put it over here, and its diameter has to be the diameter of my base circle. So the diameter of my base circle is 0.94 minus 2 times the clearance. No, sorry, the diameter of the clearance circle has to be the diameter of my dedendum circle plus 2 times the clearance. So this circle plus 2 times the clearance. 2 because the clearance is a radial measurement and we are working in diameters. Had you been working in radii, then you wouldn't have had to double it. So the diameter of my dedendum circle is 0.69 plus 2 times the clearance, and the clearance is 0.03125. So this circle is our clearance circle. I'll eventually get rid of this. If you wanted to be very thorough, you could have made this as a separate sketch and refer to it within this sketch, but I'm being lazy. Or one could argue I'm being efficient. If we know that we don't need that extra sketch, then by making it and having it consume some of the computational power, you're making your final model more computationally heavy than it needs to be. But either way, it's not a big deal at this stage. So what we want to do is that we want to connect the end of our involute profile to this clearance circle along the radius. In this case, the radial segment would be or a horizontal line, because if you extend that crosses through the origin. I'll stop over here, and then you could use the fillet command, play around with it, or if you're not very concerned about the dimensions, you could use arc. A simple arc over here that might work is a 3-point arc. So select a point over here, select a point over here, and in this way I've created a curved feature which is a fillet. It's not a very precisely made fillet, but it is a filleted feature, and that's good enough for this project. So now what I'll do is that I'll get rid of this clearance circle that I made, and I'll complete half of the profile over here, and then I'll mirror that about the center line to complete my profile. And when I press the center mouse button, we are being told by Creo that this is not an enclosed sketch. Hence, even if we wanted to extrude at this stage, we won't be able to, and we know where the open edges are. So again, going to arc, center and ends, and I'll start from here, and I'll make an arc up to this point. Now the right portion of my gear tooth cross section is complete, and I'll select the sketched lines and arcs, which once I mirror them about this line would complete my tooth profile. So I've selected these three because they're missing over here. I'll select mirror it about the center line, and I have completed my tooth profile. The tooth profile should be involute. The involute portion starts from the base circle. Below the base circle, we have a radial segment which turns into a fillet at the clearance circle, and everything stops at the dedendum circle. So this is my tooth profile. So yeah, that was a lot of effort just to make a profile. We don't even have a tooth yet, an extruded tooth yet, but this was the difficult part. Everything after this is simple extrude operation and pattern and removing material again using extrude. So I'll call this sketch my gear tooth profile, and I can extrude it. And in the problem statement, you are told that the thickness of this gear should be 1 centimeter. So this is your gear. This is 1 centimeter, and 1 centimeter in inches is 0.3937. So that should be 1 centimeter, and you don't have to, but I prefer to extrude things symmetrically. So you could use symmetric extrude, and in this way you have your first tooth. Now we need to make the hub or the wheel of the gear, and for that we will select our dedendum circle. You can select it from here. That's this circle. Extrude it, and you could enter the same value over here, or another way you can tell Creo to what surface you want it to extrude to. You could tell it, give it a reference. I'll give it this reference. This will become tricky because I chose symmetric. Had I not chose symmetric in the previous step, I would have just given it this reference, and everything would have started from the same plane, and I would have been done. So I actually complicated things for me. But still, hopefully you are able to appreciate that if you don't know exactly what this dimension is, or you don't want to dig in and find out what the dimension is, you want to extrude something up to a certain surface, you could just select that surface. But over here, I'll give it a value which I know is 0.3937, and that gives me the core portion of my gear. And I'll rename the extrusions as well. The first extrusion was gear tooth, and you can rename the second extrusion as you wish. And now it's a simple matter of axially patterning the tooth to make 8 teeth that are needed. In my case, in your case, you will be required to make a certain number of teeth. Pattern, axial pattern. I'll pattern it about this axis, the Z axis. I want 8 number of teeth spread evenly about 360 degrees, and in this way I have been able to create my spur gear. I'll very quickly remove some material for the shaft. I might not do it completely because we have done similar things in the past, so you know how this is to be done. But make a new extrude. The diameter should be 1 centimeter, which is 0.3937 inches, and it should have a keyhole. You have some requirements about the size of the keyhole, so keep those in mind. I'll just make something that looks reasonable to me. I'll make it slightly bigger. So I'll use this as an opportunity to showcase one more feature of Creo. So if you want to change a dimension, you can double click that dimension and enter the value manually. But if you don't know exactly what you want the dimension to be, and you want to play around with the sizes and see how that affects things, then you can select, let me deselect everything, select the dimension and use this modify option. So single left click, wait for this menu to appear, and then modify that option, or you could do it from here as well. When you click modify, this knob or a wheel appears, which allows you to increase or decrease the dimension. You could even change the sensitivity, that how much does the dimension change every time you turn the wheel. And if you want to see the effect of increasing or decreasing the dimensions and where it looks reasonable, you can use this. It's a very useful tool. You can add more dimensions to this as well. So this looks like a reasonably sized keyhole to me. I'll just center it, and then I'll delete some of the extra segments to make it one closed feature. So when I remove these segments which are highlighted in green, I should have one closed feature, and that is the case. So the one closed sketch, and now I can extrude it in the negative direction to remove material, to allow my shaft to be stuck in, and a key to be inserted. So this is your spur gear. A few requirements, additional requirements mentioned are to get rid of extra sketches that you have made over here. If you want to take a picture and use that to communicate your design, having these extra sketches which were only there as sketching aids, they don't need to be there. So removing them would make your communication more efficient. And then I want to annotate the dimensions of the pitch circle and the base circle in millimeters on my figure. So the first thing I'll do is that I'll select this addendum circle. You could select it from here as well, and then I'll hide it. So this option over here hides features. So this feature still exists, and if I want to work with it later, I can unhide it. I can unhide it using the same option, the first option, but I don't need it. It's in the way, so I'll hide it. Similarly, I don't need to see all of these datums. They're in the way. I'll hide those as well. And I'll leave these two circles, which are the base and the pitch circles. And I'll annotate. If you go to annotate, the third tab in Creo, annotate their dimensions. So actually, I do need the plane display. So I want my annotations to appear in this plane. So what plane is that? From here, you have to select a plane. So the top plane, which is highlighted over here, seems to be this plane. The right plane is this plane. And the front plane is that plane that I wanted to work on. Creo highlights it for me and tells me what it is. And then once I've selected the plane, this is the plane in which my annotations would appear. I'll choose dimension from here, and I'll select initially my pitch circle, and I'll pull out I want it to appear somewhere over here where I'm happy. I'll just left click, or actually center mouse click, and orient things here where they make sense. And you see that this annotation is telling me that this circle has a radius of 50. It's 50 inches. It's sorry, 0.5 inches in this case. I know that because I know the system of units is inches, but it's not very clear. So we'll select this annotation, and we'll, within the dimension tab, modify the dimension text. In the dimension text sub window, you can add text as you want. So what I want to write over here is that this is my pitch circle with the following dimensions. So at d over here is the value of that parameter that Creo automatically measures and reports over here. And at the end, I also want to mention the units. So the units over here are inches. So I've written inches. So over here, now it says pitch circle has a radius of 0.5 inches. I can increase its size by going to format and increasing the height to 0.1. That might be a bit too big, but let's just go with it. So in this way, I've added an annotation to my gear. Similarly, add another annotation for the base circle and take a picture like we've talked about in the previous slides. Get rid of extra datum, from here, and you can also play around with the appearances. Try coloring this as you want. You might want to give it a metal sheen, and you could also take a picture without the edges, with just the shading. That's a more photorealistic rendering. Yeah, that's it. Do refer to the instructions about submission that are there in the instruction sheet. There's something wrong happening over here, so I'll take a look before uploading. You have to upload your part file and also a one-page PDF that you have to print and bring in class that I'll be using for grading. Thank you very much, and please reach out if you have any questions.